नमस्कार। एस क्यूब टीवी में आप सभी का बहुत बहुत स्वागत है। मैं हूं पूर्णिमा शर्मा और आज हम चर्चा करने जा रहे हैं विज्ञान पर, तकनीक पर, किस तरह से साइंस एंड टेक्नोलॉजी इज हेल्पिंग अस इन डीलिंग विद द पेंडेमिक, with COVID-19, and do we need to reorient our focus on research and development, on science and technology at the policy level? Because जिस तरह से हम अभी तक साइंस और टेक्नोलॉजी को देखते आ रहे हैं, वो एक इस तरह से देख रहे हैं कि वो हमारी लाइफ का हिस्सा है, लेकिन उतना हमने उस पर ध्यान नहीं दिया। लेकिन नाउ दैट वी आर फेसिंग अ पैंडेमिक, a crisis situation, so we are finding solutions through science and technologies, and science and technology is at the forefront of in dealing with this pandemic. And to discuss this, I have a very special guest with me. We have Professor Ashutosh Sharma, who is Secretary, Department of Science and Technology, Government of India. A very warm welcome to you, sir.
Namaskar, Purnima ji. Namaskar and hello and good evening to everybody who is watching this. I'm so glad you're discussing science and technology, especially in the times of virus. So, indeed, you see, science and technology is important in everyday life. We are all surrounded by it. If you just look around yourself, you see there is not single object you can find which is not a product of science and technology. But science and technology is like air. So you don't notice it because it's everywhere. And it's only in the time of disruption. It's only at the time when something very different happens that we have to wake up to the fact that the solutions have to be sought in science and technology and innovation, which is fueled by science and technology. So this is indeed a very good thing to discuss. Before we go further, I always share with my viewers, with my friends, that we should all wear a mask. This is a homemade mask, but it works very well for this virus. And because there is no cure, there is no vaccine. So what we need to do now is to prevent the transmission of the virus. And to do that, the most important thing that we can do is to wear a mask. So you are safe and everybody around you are safe. And so together with physical distancing, more than 6 feet distance, and sanitizing our hands and surfaces that we touch frequently is the way to stop or minimize the transmission of virus. And it's just I'm not wearing a mask now because in this whole big room I'm all alone, right? Otherwise, of course, that we would be wearing it, and this is my request that we follow all of these practices rather strongly. Now, the point about science and technology is even more important for this virus, and the reason is this: this virus is little bit mysterious. It is a little bit mysterious in its behavior, in its modes of transmission. And you know that until relatively recently, WHO said that we don't need to wear a mask. Imagine, you see, so it's not the fault of WHO necessarily. It's just that there are many things which we do not know about this virus. The mode of transmission, the incubation period, the immunity that comes after you are cured, and what are the things that the virus attacks? What are the modes of attack in the body? Right? What are the different things that it affects adversely? Of course, they are lungs. The other limited studies might show other things. So there is nothing conclusive about the virus. Now, the reason I'm saying this, there are two things, there are two aspects of things not being 100% known about the virus and its transmission and its therapy and the vaccine and the preventives and so on. So what that means is that science and technology has to play even greater role because when something is unknown, you have to start from ground zero. Of course, you start with all the resources you already have, all the infrastructure, all the knowledge that we have over the decades. We make use of all of that. but you have to start building from there every day. And so, certainly, science and technology is a big aspect, together with, of course, the policies, the regulations, the standards, the laws, everything works together, right? So, now science and technology has many different components that go into it. So as we know that there are so many different verticals, how do you disinfect? How do you sanitize? How do you recycle, for example, or reuse PPEs or protective gear like mask and so on? What about the ventilators? Right? So some people, maybe, hopefully, a very small percentage of people might require ICU support and ventilators, but there are many different kind of ventilators. You see, so while some aspect of science are global, technology is often local. So in these times, globally, in fact, people have been working on new designs of ventilators, some which are very inexpensive, which are not invasive. Invasive kind of ventilators, you require a very expert medical personnel, doctor actually attending it. But many other cases, perhaps as many as 10% cases, what one requires is some oxygenation, some kind of support for lungs, and that can be done with ventilators, which are far less expensive and much easier to operate. Some of them might want to operate in home settings and so on. So there has been a global race to find new convenient models of ventilators, for example. Of course, there is a whole thing about the diagnostics, right? So we need to have new kind of diagnostics, which is much faster, cheaper. So that would allow you to actually test much larger number of people, and so on. So there is the diagnostics. Well, then of course the vaccines, and the war on vaccines is just heating up, and then the therapy or drugs. So these are so many different compartments in which science and technology has to address the problems related to this new virus, this mysterious friend that we have with us now. So certainly, the point about science and technology, like I said, people had to start from ground zero on this, on a whole lot of things, but they made very rapid progress, extremely rapid progress, and that was possible because people felt the urgency of it. They felt it personally. See, a whole lot of science and technology may be impersonal, right? So okay, well, there is some industry going up or something. It's just a little bit remote from people, but this is something which is clear and present. So people feel that they are fully committed to it, and so that a very rapid progress indeed was possible. Um, and this progress, like I said, is happening on many different fronts. Now, these fronts would be basic research, which means knowing, well, what's the mode of transmission, how does the virus act, what is the action pathways, how to block them. So a whole lot of biochemistry, biophysics, all sorts of biological and life sciences basically come into play, and so people start doing that, or sequencing the genome of a virus, looking at the gene structure and so on, looking at the morphology of virus, looking at what are the conditions that affect the virus. For example, there's a lot of talk about, well, what happens if it's hot? What happens when it's humid? What happens when you shine ultraviolet light on it? What happens when you spray some chemicals on it? So all of that is basic sciences, and all of that information is needed going forward to make more rational decisions. Also, yes, go ahead.
So, as you have shared this information about the nature of this virus, which is mysterious, and we need a greater effort, especially from the field of science and technology, to understand this virus and to tackle it. Do you think if we are going back in time on 17th November, this we got to hear about this virus, it surfaced. Then December passed, November passed, January, we came to January, and then we were not told about its human to human transmission nature of this virus, that it is genetic. And then on 30th January, we got to know it's a global health emergency. And then January passed, February, we didn't know much about this virus, that what are the precautions we should be taking. And then on 11th March, almost 4 months have passed. And during this time, which has been wasted, and do you think there was too less time for the scientists and the medical fraternity to prepare to tackle this pandemic? It was too late to inform the world about the nature about this pandemic. I mean, there were some gaps which should not have happened.
Yes, that's a very good point. And indeed, it's very important in science that, especially in something like this, that we share our information, that we share our data. Because you see, it's not about something which affects one nation, one society, one person. We are all in it together. So that the fact that there ought to be insight that we are all in it together, that we are the world, so to say, this is what joins all of the humanity together. That we are indeed, are affected by what other people do, and in turn, we will be affected by what others would do in turn. So, unfortunately, that I agree with you that it didn't happen in time. That until very late, people were not even sure how it transmits, and so anybody who had the early data, early information and knowledge about the virus and its ways, it would have been much better for the whole world if that information was known in time. So it is. So anyway, going forward in the future, it's our responsibility as scientists, as scientific institutions, as even the government and industry, to share as much information as is possible. Of course, with industry, it's a little bit different because they also have to look at their bottom line, and it would not be completely reasonable to say that they are all only in social good. But at some fair pricing, they ought to be able to share information and share the technology and so on. So I think that's certainly the need of the hour, and I think the government is working very hard to make that possible. For example, many ministries working together, sharing data, information, and ideas together. That's a very welcome step. I know that there are many companies that are working with startups. Startups are working with academia. Companies are working with academia. So there are many players in this game, and usually we operate in silos, right? So that's the normal way of doing things. There's the old normal, but now this emergency, forces on us new ways of thinking and doing things. So it means that data sharing, information sharing, even patent and intellectual property sharing at fair terms, that should become the new norm because no single company, no single nation, no single group of scientists hold the entire key. So it is vital that we come together with a single purpose. While we all have our selfish interest, which is fine, this is how the human brain or the mind works. But we must understand that this selfish interest actually extends in many different directions. And this self that we talk about actually is an aggregate of many different selves in this case. And if we make sure that these other people are doing well, then we are also doing well. It's happening, I think, and that's a very welcome thing. It's happening more and more, and I'm sure that this would happen even more strongly in the times to come.
So we heard the news in recent days that faulty kits or substandard kits or contaminated kits being exported from China to different countries uh, in Europe and to India too. Looking at what we are getting from other parts of the world, do you think that we need to focus more on now on indigenous technologies and products, because the narrative is somehow, after seeing this scenario, is a focus should shift from globalization to indigenous technologies, and what are our efforts in this direction?
Yes, you see, whenever there is an emergency of this kind, there are lots of fly-by-night operators as well. And this is something that one has to be careful about having substandard things. Maybe, people make this mask and put in N95 on it or whatever. I agree that, that some of that happens, right? And so faulty things which are put together in a big hurry without paying attention to details and standards would happen. By the way, it also happens in the arena of news. There is a lot of fake news, incomplete news, planted news, all of that happens. So everywhere, whether it's technology products, whether it is informational products, all of that one has to scrutinize rather carefully. And so it is true that we had to import a lot of things in a bit of hurry for obvious reasons. But I'm sure that there is a good, practices being followed in terms of testing. So, for example, ICMR immediately stopped the use of that particular batch that was imported, which was found to be faulty. And it's not just with India. I think we have heard this before. Many
With
nations were complaining.
UK, with US, yes, yes.
Right. So this is in the nature of things that one has to be more careful about what you hear, what is on my WhatsApp group. One has to not just start believing everything. You have to go through it with a magnifying glass. Um, in fact, the scientific method is something like this. In fact, Gautama Buddha said this 2,500 years ago. He said, believe nobody, don't believe me, unless it squares with your own reason and experience. That was among the first statements of science, so to say. But we do get carried away sometimes, and we are not that critical about judging things. But this is a general appeal. I would say many of these things, the news which float around, I put them under a lens. How do you do that? I search for fake news. There is also, repository of fake news. So oftentimes it would actually show me that this is not correct, that this is not trustworthy, or this is incomplete, or this is just one perspective. A whole lot of that, goes around. People get worked up. They say, hey, there's a new therapy, and let's pop some pills, or they experimental things. People just read something somewhere, and that one ought to be very careful about. Do not do anything except with certified doctor's advice. And so I would in fact say that there are some experimental drugs there, some experiments, the controlled experiments are going on, but those are under supervision of proper team of doctors and under certain conditions. What you give, actually what you try on a critical patient is not the same thing you would try when you have slight cough. So it's very important that we just don't read something and then hoard up on things which are not required and start popping pills. Indeed, it could be rather dangerous. There is right now no certified approved therapy, and there is no approved vaccine. There are a lot of things which are happening at a breakneck speed, but we have to wait for them to basically come through, and then that would become the normal course of therapy and so on.
So amidst all gloomy news which we are hearing about the nature of this virus, it's mysterious. We don't understand. We don't have vaccine. We don't have any drug. At the same time, there's some good news is coming from S&T community. I would like you to speak to us about a unique experiment that has taken place, and we are first among the world of this RT-LEMP test. So, what this test
Yeah,
is all about?
among many things which are happening really, really rapidly. And this is a good example because this is a fast and cheaper diagnosis for SARS-CoV-2 virus. Just like the another test which is considered reliable, which is called RT-PCR. RT-PCR
And how
basically,
this PEPT is different from RT-PCR, RT-LIMS?
yeah. So it is very innovative. There are three different innovations that go into it, and very interestingly, all these innovations happened just in the last 3 or 4 weeks. And so I would come back to it because that's a very important point because there are lessons in it for other scientists. There are lessons in it for our way of doing things, for our way of doing science. Anyway, I'll come to that story a little bit later. So there are three innovations in this. The first one is extracting RNA and enriching it. Extraction is easy, but then you have a very dilute soup. It's better if you start with a lot of RNA, then you convert it to DNA, and then you amplify it. So that's what they do. Um, that's what they do also in PCR. So the first step is actually to get RNA in quantity, in bigger quantity. Then the subsequent test would be faster. To do that, the Sri Chitra Institute of Medical Science and Technology in Thiruvananthapuram, they came up with this idea that these RNA strands, which are floating around, if we conjugate them with magnetic nanoparticles and then use a magnetic field like a magnet to pull them all in one direction and then remove, of course, the remaining liquid, then you have a more concentrated soup that you begin with, which means that you got more RNA, strands which are floating around there. You start with that, then basically you make DNA copies with it, this RNA. The second thing is that you pick up a particular gene of this virus, which is called N gene. There are four different kind of genes in this virus. They produce different kind of proteins. Some are, produce the envelope of the virus, which is called an E gene, and so on. So N gene is a particular kind, is one of the four genes, and then there are two segments in that gene that we may call NA and NB, that they are unique signatures of this particular virus. So if you can identify these segments of the N gene, NA and NB together, then you have 100% certainty that it is this virus and nothing else. So to do that, then you go to what is called formulating a primer. So these primer in PCR, there are two primers that are used. In this particular lamp, they came up with six primers. So basically, these primers, they go sit at these fragments, the fragments of N gene, and then while that these are amplified. So the DNA, the DNA that we are working on now, and then we have the same domains NA and NB there. The DNA fragments are multiplied at a constant temperature. Once you have sufficient amount of DNA, then it can be captured in what is called fluorescence signal. And this happens within 10 minutes. This happens within 10 minutes. And the other thing is that you have to use a particular wavelength of radiation to excite the molecule, the segment, and you need another wavelength at which you pick up the signal. So these two wavelengths, nobody else knew. So they had to do experiments to pick up, okay, at what wavelength we are going to be seeing or sensing the presence of these domains NA and NB. So this is part of their patent. So I cannot tell you what that wavelength is. But anyway, the point is that these are three different innovations that made possible for this platform called LAMP to work for detecting this virus within 10 minutes. Now, 30 tests can be done simultaneously within these 10 minutes. So there are 30 different wells. And in fact, one can add more. So now the improved versions of these machines will have 100 wells. What that means is that you are testing 100 samples together within 10 minutes. Now, if you compare it with the PCR machine, then it takes about 2.5 hours to run the same cycle the test, right? Of course, the time for sample preparation still remains the same in both the methods, whether you do it with PCR or you do it with LAMP. But basically, the testing time is cut down a lot. The second thing is that essentially with one machine in a day, you can do about 1,000 samples easily. If you run 2 shifts, 3 shifts, something like that, and you are running 100 wells at a given time, in fact, you can even do multiple thousand tests with a single machine in one day, right? So imagine that if you just had thousands of these machines across the country, that would be doing nearly 10 lakh tests per day. So therefore, that basically you start testing with the scale and with the speed. These are the two things that we basically need in any diagnostics. And the third thing that you need is basically that it has to be trustworthy. So the test has been, well, that this new test, it has been validated at National Institute of Virology, which is the nodal lab for certifying any new test. Their results have gone to ICMR, and as we speak, another 500 tests are being done. Okay, we just want to be, not like the example that you gave earlier. You say, well, okay, half-baked stuff being pushed somewhere, right? We want to be sure that this is meets all the global benchmarks, meets and beat them, right? So this is not only a product that would be only for India. This should be a product for the global market, and indeed because everybody is looking for a test of this kind, which can be done on mass scale, which can be done conveniently. You don't need as much trained technicians for this test as for PCR, right? And so it's totally good. And this the new cycle of testing which is going on now would be concluded by Sunday. Okay,
Okay,
and
that
then you get into production or manufacturing, for which tie-ups are being done with several companies, so that this could be done very quickly. And so it's a very positive example of what our scientists could do if there was a sense of purpose, right? So there are several things that you can learn from here. They say, look, there is a clearly defined objective, right? So it's not like I'm just doing what I feel like doing, right? My own thing. But there is a purpose, there is a very clear objective that we need to get there, and we need to get there quickly. Second thing is that, of course, that we need to have previous infrastructure and people, trained people to be able to do that. In this case, both were available because just about 4 years ago, we set up a center on technology research in Sri Chitra Institute. So basically, idea was that the biomedical devices of all kinds could be made there, could be innovated there, because there are clinicians working with basic scientists and also working with engineers and technologists. So all of them working together make it possible to make stuff like this. So if we don't work in silos, if we have a shared purpose, if we have a clear vision, we are driven by it, we have previous infrastructure and knowledge that we can harness, then it's going to work. And in this case, they were working on this platform for TB detection, so that they
so
already
the
have.
process was already in place.
Well, yes, not all the process, but the basics of how you think about it, the basics were in place. And if they were not, then of course it's not going to happen. So the question you were asking about, look, in the times of peace, we may think, look, what's the point? Okay, well, TB is there, but TB has been there for many decades. So, it's not, it didn't, it didn't press us so hard. So in peace, times of peace, we may think, oh, do we really need to do this and stuff? All the investment that one is doing, is that going to be useful? People have that kind of doubt. But you see, unless we have seeded that knowledge, unless we have human resources who are fully trained in these things, unless we have basic infrastructure, then in the times of need, you cannot just go from 0 to 100 in 3 weeks. In fact, the biggest of the companies in the world have not been able to do it, right? So it's not, so of course they have the resources, they have the trained manpower, but then you see some amount of creativity and lateral thinking plays a big role in it. And if I may say so, finally, even though many scientists don't like the use of that word, it's called luck, right? Because not everything happens only by infrastructure and people. Some of it sometimes clicks. In many things in science, they don't click. So you have to keep working hard and you fail and then you try again. Eventually, something would click, but it takes time. So there is an element of luck that plays a role in it. In fact, I was talking to the scientist, Dr. Anoop, today. Very long talk about. I was interested in knowing not just okay that this is happening and the technical details, but the process behind it. I said, so how did it happen? I mean, your students, there were six PhD students. Weren't they away because there was a lockdown? Right? He said, oh, actually, four of those students got locked down in the campus. Right? They were not allowed to go out and go to their home. Right? They were from out of town. So wasn't that kind of lucky? Right? Because then he could ask these people who were then doing nothing else, saying, hey, let's work with this virus, let us use our platform, let's use all our knowledge and see whether we go forward. Now imagine if it so happened that those students had all left, then there would be nothing, right?
So the
So these
platform
are
was
things which are
already in
not
place
controlled by
that helped
science.
you.
They are controlled by coincidences, happy coincidences that happen. Whole lot of breakthroughs in science happen because of some sudden flash of insight, but it's not like it was very logically thought of, right? It just clicked, and then there were right situation, right circumstances, conditions that made it possible. And so this is one example of that. And so many things, technology is developing on many fronts, science is developing on many fronts, and we will see many more innovations coming from India. So your original question was all about innovating in India, about making in India, indigenous technology. All of that certainly makes sense, but there has to be a balance. You see, we do live in a globalized world. So what that means is if you have a technology already available, which is not critical for your strategic needs, and maybe it is much cheaper, then industries tend to import that, right? And we cannot and we should not completely stop that process, right? But at the same time, we have to look at where is our strength, where is our critical needs, and those things. To give you an example, there are many countries that grow their own staple, food, right? Even though they can import it much cheaper from somewhere, but they say, look, this is something. This is my food security in a sense. What happens if this country ABC starts saying, look, I cannot supply you this much amount of this stuff in this much time, then
So,
you're
sir,
stuck,
do you
right? So
do
yes, so we should have, and moreover in manufacturing, I completely agree that we have to be far more competitive than we are now. So manufacturing is a sector that we ought to do much better, and we can do much better. I mean, there is not a slightest doubt in my mind that we can do much better because the science and technology that you need to be competitive is there, or it can be developed very rapidly based on demand, right? So whole point is there is a science and technology getting into industry is a two-way process. Is that you need to have the right science and technology, but you also need to have a pull from the industry. So there is a push process and there is a pull process. So these two have to basically combine together. So the industry has to see the merits. They have to see the merits of harnessing the local R&D, right? I mean, so on day one, you see, none of the countries have built on the strength of their R&D overnight. That never happens. That has never happened anywhere. So it happened over years. It happened over
true, sir.
decades. We have
True.
to make a big.
As you have talked about speed and scalability, why what time this RT-LEM technology would be available, as you said that it's already been approved by National Institute of Virology and ICMR. Now, by what time it would be
I-
available for public
I'm
testing?
thinking
And
that within a week or so, that everything should be formally approved. Of course, I cannot, say it because I mean, I'm just my guess.
your part is
Because the ICMR has to take a call on it, and I'm sure that they are working very hard to take a call on it. And after that, it gets into manufacturing. So my guess is in about 1 month, we may start seeing the first machines for use. And after that, after that, it scales very fast because everything is in place for manufacturing. So if you first make the first 100 machines, there is a bottleneck. After that, you can make another 1,000 machines in equal amount of time,
and
right? So it should be within a month or two that we start playing with these machines at scale.
and do we have the material available to manufacture this machine, or do we need to coordinate with other nations, or we need to manufacture it in our own country? And
There's no single nation that has all the components for building anything high tech, right? So certainly there would be some import, but all those processes are in place and they are under control.
so this machine, I heard that it is also cost effective. It's much lesser than in price
Yeah,
to the
the point I forgot because I got
RT-PCR.
into science of it. Of course, what is important for people, for us, is the speed and the cost and the accuracy. So accuracy is 100%, and so once it's certified, you would know about it. The speed, as we said, well, you can do 1,000 tests in a day in a single machine. And the final thing about the cost. The cost of this machine is about 2 lakhs as compared to PCR, which is upwards of 15 lakhs. And the cost of test would really depend on, okay, company which is doing it and so on, but it cannot be in excess of 1,000 rupees. It could be much less. I'm hoping it would be much less because once it's deployed in numbers, right, then my expectation is that it would be much less than 1,000 rupees. But 1,000 rupees is the upper limit as compared to what you pay for PCR. Even if a patient doesn't pay for PCR, somebody is paying for it, either government or anybody, but it's upwards of 2,500 rupees per test, and it takes much longer. But
And the
this,
sample collection process would be similar to RT-PCR also.
what process?
Sample collection
Sample collection is the same. You take a swab and collect from here and here and stuff. But that's not really
and
about
quick
that.
result it would be giving.
What?
It would be giving quicker result than the other testing
Yeah,
kit.
yeah. Because you see, 10 minutes versus 2.5 hours, right? So therefore, you can do many more tests, and you can do with much less, cost. So, but this is only one example. I don't want you to get stuck only on that example. You see, many
And
things are
now
happening parallel track.
about the initiatives of
Yes,
science and
labs
technology.
are doing great things. They are coming with another test which may be much cheaper and faster and accurate. And it's not just diagnostics. On vaccine, things have started moving. Lots of good designs for ventilators have come and they are being manufactured. I'll tell you, basically, we have been all the science agencies, including the Department of Science and Technology, are moving on multiple tracks. So, what are those multiple tracks? Because it's a multi-dimensional problem. So the first track is the basic science. So we had a call out. This basic science includes the behavior of virus, how it transmits, what effect it has on different organs, and so on. Right? What is the latency period of the virus? How long the antibodies that are formed survive in the body, and all those things. Basic questions that we need to know. So there is a call out for that, and including also the modeling and simulation. So if we can have right kind of modeling and artificial intelligence, machine learning, everything plays a big role in it. Also, having the right kind of data plays a very big role in it. That's why I keep emphasizing that we need to share data. Others should share their data with us, and we should share our data with them so that it's helpful to make new, improved, and much more reliable models for predictions So some decisions could be made on that. So there is a basic science approach for which many projects are now being funded already in the last 3 weeks. We made our processes of funding very fast, our processes of scrutinizing the projects very fast, and so on. And the second track is basically looking at the startups. So first thing we did is made a mapping of startups. Which startups could be helpful in addressing the solutions for this problem, and then which of these are nearly ready, so that by little push they can get into manufacturing, right? So now the seed funding for startups is being provided. Already we had something like, I think, 300 applications from startups. They have been screened. The first lot of them is ready for funding, and we would do it very rapidly. So these startups have various solutions in all the different verticals of this disease to offer. Third track are the industries. So industries which already have a proven product or technology, but they need to scale it up very quickly, and for that they need capital, right? So the third track is through this technology development board, which is basically commercializing indigenous technology. To give you a recent example, just 2 days ago, we had made the decision to support a PCR kit maker in the country, which is called MyLab in Pune. So this is an example, the third track, which is, well, you have a product, you have an industry making it, but now we need to accelerate the process. So instead of making, for example, 30,000 kits a day, let's make 1 lakh kit a day, right? So these are three different tracks that I talked to you about: basic science, startups with applied science and a product nearly ready, and the industry that need to scale up. But in addition to these three, there are many important tracks we should not forget, which are related to science and technology. One of those tracks is actually science communication, right? And so we have made actually a lot of this content, which we are now going to about to distribute, which means the right kind of information about COVID-19, but also giving people, right kind of motivation and so on. Another track is working through NGOs. Now, you see the self-help groups, local groups, they may make disinfectants, if we give them the recipe. They make very nice masks, you give them the recipe. They also give information about how to break the chain of transmission to the local community, right? Because we are not there everywhere, right? It has to be done by people. If you want the scale, if you want the speed, you have to draft very large number of people. And so NGOs, for example, do that job, and we are already supporting close to 50 NGOs across the country, which have very ambitious plans, which they already started doing. So mid-size, large-size NGOs that have the muscle, and they are fully committed to this, from all the activities that I told you about. In addition to that, we are we had recently launched a big mission, a national mission, is called Cyber Physical Systems. Basically, the core of it is related to artificial intelligence and machine learning and IoT. So all of this mission is also
You are
being
seeing
pressed.
solution to current public health in future technologies like artificial intelligence.
Absolutely. So we are pressing this mission, and the people, they are the best of brains in this country. They are both from industry as well as academia and R&D labs. We have activated that group. I said, look, you look at the problems related to AI, which anyway they were going to do, but now this is the short-term goal. The short-term goal is let's investigate this, right? Whether it is in terms of modeling, whether it is in terms of diagnostics. For example, you know that looking at the CAT scans and X-rays of the chest, that it is possible actually to do diagnostics. In fact, to do as good a diagnostics as PCR sometimes, but it has to be driven by artificial intelligence, machine learning, and so on. So there are many problems of this kind which are being looked at by this group of people. Similarly, for many of these, for simulation, modeling, AI, you need huge computational resources. So we have set up actually, we're going about setting up supercomputers in the country. That was another national mission. So these computers now can be used for this purpose. Also, some companies, for example, IBM, have come forward and offered their global computational resources for this purpose. So we have connected all these groups with companies like this. NVIDIA has come forward to give us a stack of software solutions that they have. So working with these companies, that we bring this muscle which is required in a very short time. So I'm very glad, this is another example of people working together. So it's the industries, both the global industries, the local industries, startups, academia, R&D labs, ministries, everybody working happily together. That's the
तो सर,
message.
जैसे आपने बताया कि एनजीओस है, सेल्फ हेल्प ग्रुप है, उनके साथ काम हो रहा है फेस मास्क पर, और चाहे फेस शील्ड हो, हैंड सैनिटाइजर हो, हैंड वॉश हो, और कई एनजीओस के साथ मिलकर एसएनटी काम कर रहे हैं। इसके अलावा स्टार्टअप्स के साथ मिलकर काम हो रहा है, मैन्युफैक्चरिंग इंडस्ट्री के साथ मिलकर काम हो रहा है, इंटरनेशनली कोलैबोरेशन हो रहे हैं, उनसे भी इंटरनेशनल जो इंस्टीट्यूशंस है या कंट्रीज है, हाउ यू आर कोलैबोरेटिंग विद देम in order to deal with this pandemic?
Yes. So one of the very big fronts in international cooperation is related to vaccines, because this is a very complex thing. It's not advisable that a little entity does it on its own. So this is being looked after by Department of Biotechnology and ICMR, that we plug into these big trials which are going to start globally. So that's one way to connect. In addition to that, on all the smaller fronts, we are connected with several nations, which means that we are working together to form these groups. Essentially, the way to do it, the way we are doing it, see all these projects that we are giving to startups, that we are giving to academia, to R&D labs here, we pass on to them all the information that we have about the foreign companies which are working in their own countries, about what they are doing. And then we are saying, look, you have a dialogue and see whether you want to work together. If you want to work together, we would do the funding for that cooperation as well, right? So this is basically working proactively for our groups, to connect our groups with the groups which are relevant for this particular problem working somewhere else. So that has started to happen. You had also talked about artificial intelligence. Similarly, many other things like IoT would play a very major role in it. Let me give you a very simple example. See, we talked about ventilators, which are used in ICUs. Now, this requires a very tight medical supervision. A doctor for anesthesia and all of this stuff. But you see, now there are new designs for these ventilators. They're coming out from India, Indian design. I was very happy to note that they work on IoT. Basically means that a single doctor can actually monitor 20 different ventilators, right? So by using artificial intelligence, we also make the functioning of these ventilators much better, because a ventilator is actually a cyber physical device. It has to make many decisions, right? So depending on what you monitor, you have to change this, you have to change that, you have to change the frequency of pumping, you have to change the amount of pumping, whole lot of things, right? So these parameters can be determined by use of artificial intelligence. So both monitoring as well as decision making could be done by these devices, and so that is happening. And indeed, this is a model that I saw coming from IIT Kanpur. They had one of the early people who designed a new ventilator, right? And I think it's going into production very soon, or may have gone into production. And so this is happening at every level. This kind of innovative spirit, the spirit of dedication for a cause, that's like, has really caught on in a very big way in scientific community.
So, I would like you to enlighten us about plasma therapy, because on compassionate ground, it was given to a patient who was critical, and there was no other option available. And he has shown signs of recovery. And plasma therapy, being, we heard that it's been used in China too, and earlier too, in dealing with other epidemics like Ebola or many other disease. So, where are we in the approval stage, and what are the prospects of curing? Can we see it as a ray of hope, plasma therapy?
Oh, certainly there is a ray of hope, but it's not an approved therapy yet. So it's an experimental therapy. It's going forward. Several studies are beginning, so we have to wait for their results, right? But it certainly looks promising, and which is why people are pursuing it. If it was not promising, then they would not pursue it, and it has been pursued in limited scale in several countries, right? But we need to be sure that this is helpful, not only for critical patients, but also people before they become critical. So you see, these are many unknowns. We talked about the fact that this is a little bit mysterious, right? That mystery needs to be solved. For example, at what stage do you contemplate the starting plasma therapy? It should not be too late, should not be too early. So all of that kind of data is not understood yet very clearly, right? If it's too far gone, there's no point starting any therapy, right? So one has to be very clear about what is the right point of intervention in this whole chain of disease, that this therapy might be useful. For what kind of people it may be useful. So one has to look at all the conditions. But
So,
there's
sir, do
certainly
you?
hope. Okay, having said all this, my intent was not to discourage anybody or you, that there's certainly a ray of hope, and this is one of the tracks which are being pursued very strongly globally as well as in India now.
So, sir, do you think that we need to now focus more on R&D and to compete globally? As you have said in the beginning, that it's science and technology is like air. We have everything based on it around us, but we need to reorient our focus on research and development. And also, do we need to increase our budget on science and technology, and probably reframe our policies to find solution? Like it is teaching a lesson to us that science and technology is at the forefront when we are dealing with this pandemic. We're looking up at our scientists to work together with our medical staff and deal with this pandemic. So what are your views on this?
Do we need more R&D? Do we need more emphasis on R&D? Certainly. Okay, now, but let's look at the problem rather critically. Um, you see, budget and funding is one aspect of R&D, but it's not everything. Now, just take this example that we have been discussing at great length, which is this new diagnostic method coming up very rapidly. No new money has actually gone in there, right? So, so what I'm trying to actually drive at is that it also requires some changes in our processes. You see, what are these processes? So one thing is, actually a lot of people say, look, maybe there's some weakness in our R&D, maybe there's some weakness in our science. Actually, I would like to assure everybody here that there is no such weakness. I know this because I'm a scientist myself, and I have dealt with thousands of scientists and thousands of different situations. So the weakness is not that much in R&D and the science as its translation. Now, see, translation and getting to market and it's the deploying of science, that's not entirely in the hand of scientists, right? So I would come back to the issue because this needs to be understood very clearly. Otherwise, we'll just keep going in that loop. You're saying, hey, do we need more R&D? Obviously, we need more R&D, but that would not solve all our problems because that R&D has to get into a commercial space, right?
True.
So as long as we keep importing things and we are not really pushing our own science and technology in the country, right, their fruits, right, this problem would not be solved simply by science, right? So one of the ways that science would get into society, if we just look at what are the pathways by which science goes to society, it goes through, of course, by through industry, it goes through now startups, right? And so these are really the two ways, and of course, in a limited way, might be by PSUs and the government-owned entities and so on, right? But so each one of these entities has to be fully committed to make use of our science and technology, and this is a good lesson now, because you see that if using the same resources that we had in science and technology, we are able to deploy them with a sense of purpose, right?
So we need
So,
to we
so
need to translate this technology into mass scale production. And since we have seen that a lot of medical devices we import, or in other sectors too, do we though we have technology, we have this technology available to deal with many of the issues that we are facing. We need to focus on the indigenous technology and make in India,
yes,
and convert into in mass scale, and commercialization has to take place.
yes, absolutely. So do we? I agree. We need more R&D. We also need more purposeful R&D, and we also need this little pull from other stakeholders of science and technology in the society, right? Because they are the ones who are going to manufacture and use it. So that pull is very essential. And in this particular case, everything is working because the push and pull are working together, right? So we know that there is a demand. We know that this is the objective. We know that this is needed. And so, see, imagine if Sri Chitra Institute developed this platform but there were no manufacturing. They cannot manufacture this at scale. None of the academic institutes are set up to do manufacturing, right? This is not their job. So therefore, unless we be working together with a sense of purpose and clear direction, that look, I want this technology with these specifications, these parameters. If you make it, I will take it and I would manufacture it. So that understanding is the only thing that works, right? Otherwise, your chain would be incomplete. So essentially, the way I explain it to people is say, look, there are two different things that happen. One is knowledge generation, other is knowledge consumption. So it's like any other transaction. If you keep generating something but you're not consuming it, then it's not complete, right? At the same time, you have a lot of demand for consumption, but you're not generating it, then you have to get it from somewhere else, right? So both of these things have to work together as a knowledge system, right? See, we talk about sustainability, right? We talk about sustainability. There's also a sustainability of knowledge ecosystem. The sustainability of knowledge ecosystem is invention plus innovation. So invention generates new knowledge and innovation consumes that knowledge, and both of them must be working together with the same intensity, the same purpose, right? And so I think it's happening more, which is good, but it's just to understand the mechanism of how this would happen more, right? And this is going to happen. Other thing is about, see, in a case like this, there are short-term goals, there are mid-term goals, and there are long-term goals. And there is also three different ways of solving a problem. These three different ways of solving a problem is what I call a jugaad, dhanda, and panga. So panga is disruptive way of solving a problem, and that's happening more and more. This innovation, this out-of-box thinking, lateral thinking, creative thinking, whatever you call it, are disruptive changes, disruptive technologies, which is what you call panga. So we need to have more of that going forward. Jugaad is something that we have to solve the problem today by hook or by crook. So that, in emergency, that's also required. Um, so basically, dhanda should ride on jugaad and panga, right? And so, that people should understand that there are three different ways we can provide a solution to a problem. And as far as the short-term problems are concerned, of course, a lot of our energy and time is focused on that now, right? And that is, of course, required.
So, sir, what lessons this pandemic is teaching us as far as science and technology is concerned? as we have been talking that we need to really reorient our focus on science and technology and R&D. As you have talked about, we have technology available, we have scientists who are doing innovations, but it should get translated into commercialization, into manufacturing. We need uh, technology, we need innovations. Why to import it from outside when we can manufacture it, when we have indigenous technology available, when we can make it in India.
Yeah, there are reasons for it as to why it did not happen. Um, so this probably is right now is not a good time to get into deep analysis of that. But anyway, the issue is this. Um, there's this little story about again what Gautam Buddha said. He said, "Look, if you are shot with a poison arrow, you don't go about asking who shot the arrow, what was
True.
the
So
design of
yeah.
the arrow. But if I can find out what the antidote to that poison is, then I'm all done, right? In the short term, right? So we now some things are happening in a better way, and it's something that we need to take forward with us going in the future in terms of our processes, in terms of the way we are doing things. Now just imagine we are socially connected right now, but in what is called the normal times, long time ago, seems like long time ago, that we would be sitting together in my office and having this interview, right? All this while, you see, our ministries are working in a completely different way. Our science is being done in a completely different way, and I'm sure that these elements will be incorporated in the new normal, right? So it would become normal, but it's not the same normal as the old normal, which means that their people are working together, that we are doing science not only in the tool centric approach, but also problem centric approach, which means solving problems. That while we are solving problems, we are not doing it in isolation, that we are connecting with the larger world, which means we are connecting with the startups, we are connecting with the industry to see whether what I'm doing is it going to make sense, right? If I'm just doing stuff sitting in my lab, maybe I have no idea or care about the market, right, or the needs of the country or the society, then that solution will not scale up, no matter how brilliant that solution is. So some part of doing science is to have partners which have different kind of insight, which means they can tell me, look, what should be my direction if I want to do something like this? What is the need for this solution in the society, and so on. So if there is a good hookup between the solution providers and solution takers, that would be the way forward, and that's happening now. And I'm sure people have learned that lesson from here, so that more of that could happen going in the future, which means a problem centric approach where it has to be problem centric. Now, I'm not saying not every problem in science is of that nature. So I'm not saying discard all science, right, or what is called very basic science, right? That has to continue, because on that platform or that foundation, we would build the technology of future. So the entire thing is like a pipeline, is like a chain. But the strength of a chain is only as much as the weakest link, right? So no matter if you make a lot of links very strong, but when you pull on it, the weakest link would actually break. So therefore, all the links of the chain have to be equally strong, whether you're looking at long-term basic scientific research, you're looking at technology translation, you're looking at human resources, training of human resources, or you're talking about infrastructure, or you're talking about taking that technology to market, right? In fact, this is the model we have for the national mission on cyber physical systems, wherein it's completely different from the structure of all the earlier missions in science and technology, which means that we think of this mission as an end to end chain of knowledge, which goes from, like I said, knowledge generation to knowledge consumption and everything in between. So this has to work seamlessly, because in this mission, there are also industries which are equal partners from the beginning. So therefore, people are able to do different kind of jobs. They can relate to each other, and to develop things that would make sense. Other thing,
Here I
yeah, go
would
ahead.
like to ask you that, as far as pharma industry is concerned, do you think that there's an opportunity for pharma industry because world may look at India being the third largest pharma industry in the world, and but we get raw material from other countries. Do we need to manufacture that raw material and increase and decrease our dependency on other nations for ingredients
Yeah, it's
and
not just,
become a pharma hub of the world?
yeah. Certainly, I think there is potential in that direction. And it's not just about reducing dependence on other nations, because we see other nations also have dependency on us. So as long as there is a balance between these two, there is no problem, right? So it's like say, okay, we buy some, we sell some, right? And finally, we are even. What are the things that we buy? What are the things that we sell? Depends on our strengths and our needs. No single nation can be competitive in everything, right? Whether commercially or scientifically or technologically and so on, right? But certainly, the question is whether we have the balance today, whether we have the right kind of balance in terms of what we supply and what we consume. So there is some way to go in that direction, and I think certainly opportunities are good on the horizon if we can leverage the times and the opportunities. That there is that we can have greater impact on manufacturing sector, right? So raw material is one aspect of it, right? But raw material is not everything. There are a whole lot of value addition that happens in the raw material. So often one has to see whether it is a value addition to raw material which is more important or the raw material. To give you an example, there is this a big company that we all know about. Everybody is gaga about their designs of cell phones, for example, right? It is the intellectual property and design that makes all the money. Some other nation may be manufacturing that design. They only get very small fraction of the total profits. So in today's world, let's not forget there are two different things. One is the
Scenario
intellectual
is
property.
different now, sir. Looking at the pandemic, we are sealed our borders with the other nations, and probably this time is teaching us to reduce our dependence on other nation, as we have been discussing.
No, no, no. I agree completely. All I'm saying is there is no such thing as 100% self-sufficiency in today's world. That would have been possible 100 years ago. Even 100 years ago, maybe not absolutely possible. But today's world is so integrated, so interdependent, that one should not think about the utopia of 100% self-sufficiency. That is neither possible nor desirable. But we have to look at, see, so everything requires a deep analysis of what is it that our strength is. And so, how do we leverage that strength? How do we develop new strength in the areas that require developing that strength? And those are our critical needs. So it is based on deep analysis, and it's not simply a slogan saying self-sufficiency, right? See, we should not take anything as a slogan. And so, while this is desirable direction overall, it has to be based on good analysis and good actions. And I agree with your assessment that it's a good time to actually do that,
So,
to make opportunities.
I would like to ask you that, here, as we have been focusing on science and technology or R&D, is it the right time that we need to develop a scientific temperament among people and attract young people to focus on science and technology and R&D, and we should enhance our talent pool?
Yes, scientific temper is not only for doing science. So scientific temper is a more general term. What it means is, like I said, don't just believe in something because we are not able to analyze it very carefully and very deeply or logically, right? So scientific temper is about that. Yeah, so it is certainly a solution to many of our problems. Is developing scientific temper in general masses, not just in scientists, right? So,
Okay.
of course, I mean, people often assume that scientists have scientific temper which extrapolates outside the lab. this may or may not be true, right?
Okay.
So
So,
yeah, right.
so we are producing a lot of, as this pandemic is creating a crisis for us. So, this PPE, personal protective equipments are being used. A lot of plastic is being used. Now the question is of waste, medical waste disposal. Are we also focusing on the technologies to resolve this issue so that this waste, medical, especially medical waste disposal, and because the plastic waste is a big threat for us, and how Department of Science and Technology is focusing on this aspect to find solutions.
Certainly, DST is focusing on many of these aspects. In fact, we have been doing that for last 4 years. There was a special program in biomedical waste, plastic waste, and electronic waste. These are three new types of waste, which are also, you can say, waste to wealth. For example, electronic waste, biomedical waste is very, very nasty, so we need to take care of it fully, and so on. But it's even beyond DST. So, this at a scale, we need to have some solutions which are manufactured commercially at a scale, right? Every hospital, every place where we need to address this problem should have it. There are two aspects of it. One is reusability of PPEs and mask and everything, which may be sometimes in a short supply. So there are many technology solutions which are coming up for it. In fact, DRDO is testing for these solutions. So these are based on anything from radiation. Department of Atomic Energy has offered some solutions based on radiation, based on ultraviolet light, based on spray of certain kind of chemicals which are not harmful to people, but they can get rid of bugs, right? So there are a whole lot of technologies which are being tried uh, for for disinfecting things so that you can reuse them. Also, at the time of disposal, the best is actually to disinfect anything that we dispose of. If that is not possible, then you have to contain it. So there are several techniques for containment which are coming up, and of course, containment and disposals, they form, usual practices of every big hospital. Okay, so there are many things which are evolving now, and certainly that is an issue that we should focus on very strongly, because no use being safe and then throwing it away so that other people become unsafe at some point.
True, sir. So we have discussed how this pandemic, how science and technology is helping us in dealing with this pandemic, in tackling this pandemic. My last question to you, sir, before we conclude, is that uh, what impact has it left on science and technologies technology? Uh, 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 do we need to change our outlook, the way we look at science and technology? What impact has it left on the?
Certainly. So I just repeat some of the things I said. We said, look, doing things with speed, with sharing, with collaboration rather than competition is very natural in scientific world to compete. Okay, that is how, sometimes many good things happen because of competition. So there is a place for competition and there is a place for cooperation. And to understand how we can do better by cooperation and collaboration is one of the very important lessons going forward, because none of these solutions that we see today actually would have come about or will come about if we all insist on working singly and competing and saying, oh, you make one design, I'll make another design. There would be 1000 designs, but each one of them is imperfect, right? And other lessons are about being multidisciplinary, which means all these teams that solve problems. It has to be interdisciplinary, multidisciplinary. It is a goal oriented approach, which means I have a defined problem, I need to solve that, and I need to do that in a finite time, as well as accountability and transparency. So together with the speed and all that, collaboration and industry connect and being multidisciplinary and being goal oriented, there is also the question of accountability at the end of it, and this is all being done with some amount of transparency, right? So all of these are the lessons that I think that people would think more about them, and they will see that these things work. So things that work, they kind of motivate people to adopt them. So as we will go forward, as I was saying about the new normal. Now, often people keep saying, when do we go back to normal? Right? I certainly hope that we don't go back to everything in the old normal, right? So when you say, well, when do we go in the normal? I usually ask, what are the things that you would like to go back to, and what are the things that perhaps you can do better? So that defines the new normal. Not everything from past is ideal. Not everything from past is optimal. And if we learn new lessons, one of the lessons I was saying during this time in last 1 month, we did maybe 150 meetings of this kind. Each of this meeting had 10 to 100 people in them, and many of these are overseas and so on. We could transact our business without any problem, right? Same as meeting physically. But imagine if somebody has to travel from Israel to here and back, right? How much time and money that takes, and all of that can be saved. So therefore, basically leveraging our technology tools more and more. And this would actually develop new technologies because, see, right now, for example, we are talking on a flat screen, but probably day is not very far when you may have a holographic projection of all the people sitting together and talking to each other, right? And all my gestures are actually being copied by the hologram. There is not a great technology. This can happen anytime, but there has to be a need for it, right? So if there is a need for it, if people are doing more and more of this kind of conversation, then there would be new technologies which would be, would make people even more comfortable having remote interactions, for example, right? So, so there are many things on the horizon. I think um, while these are difficult times, if we don't learn anything from a difficult time, if we don't learn from a failure even, then that failure is completely wasted. Then that failure was nothing but distress. But on the other hand, from some difficult period, if we overcome that and we learn some new things, we learn some new tools, then it has been well worth it, right? So this is the way I think scientifically about it. And of course, you see, even managing your stress, for example. Now people did not have this kind of stress before. They had stress at the workplace, but this kind of stress when they come confined to their home. I even understand that there are more spouses are fighting with each other. Okay, just because they have to be in this space all the time. So it's a new experience, right? And so there is a stress level, worries. When there is a disruption, there is a stress, and then when there is think about future, there is worry. See, there is a lot of traditional wisdom and support structures which are useful in these cases. It's not only modern medicine that takes care of everything, right? So we had made a call also in yoga and meditation focused on COVID-19 solutions. We want people to scientifically investigate what in the traditional wisdom is applicable and what is not, right? There should be no hesitation also in saying, look, this doesn't work. If I close my eyes and do this, it doesn't work. If it is scientifically proven that it doesn't work, there is no harm in it, right? But what one should do is one should come up to see what techniques actually would be helpful. For example, reducing stress in situations like this, but also, for example, boosting immunity, right? So Ayurveda, for example, claims that there are many things that boost immunity. There is no harm at all in scientifically testing those things. Not only no harm, but it ought to be done, right? And so to dismiss everything which is maybe a lot of people say works, right? That is also not good. That's not scientific. Scientific method is that you make a hypothesis, you test it scientifically, right? Using all the modern techniques, using all the modern tools in a convincing way. So that's also that's also happening.
So thank you so much, sir, for talking to us and sharing your insights, your wisdom with us. We do acknowledge the contribution of science and technology or scientist community in making us safe from such pandemic. Not just that, but making our life comfortable and safer too. हम जानते हैं कि जो साइंटिस्ट है हमारे, जो वैज्ञानिक है, वो दिन रात हमारे लिए काम कर रहे हैं और किस तरह से हमारी जो जिंदगी है उसको उन्होंने न सिर्फ सुरक्षित बनाया बल्कि कंफर्टेबल भी बनाया। हमारे आसपास जो हम देखते हैं सब कुछ साइंस पर निर्भर है। और जो साइंस एंड टेक्नोलॉजी, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, वो किस तरह से इस महामारी से डील करने में हमारी मदद कर रहा है और उसको हम एक्नॉलेज करते हैं। और किस तरह से आपने जिस तरह बताया कि एनजीओ हैं, चाहे सेल्फ हेल्प ग्रुप हैं, चाहे इंडस्ट्री है, सबकी मदद ली जा रही है इस समस्या के समाधान में और सब आगे आकर मदद कर रहे हैं। और जरूरत है कि हम अपनी इंडिजीनियस टेक्नोलॉजीज पर फोकस करें। टेक्नोलॉजी जब हमारे पास अवेलेबल है तो उसका कमर्शलाइजेशन बहुत जरूरी है, उसकी मैन्युफैक्चरिंग बहुत जरूरी है और उसको आम लोगों तक पहुंचना बहुत जरूरी है। हम इंपोर्ट ही क्यों करते रहे मेडिकल डिवाइसेस, या सिर्फ मेडिकल ही क्यों, बाकी सब फील्ड में भी, बाकी सभी सेक्टर्स में भी और पॉलिसी लेवल पर भी इस दिशा में बदलाव लाने की जरूरत है। साइंस के जो महत्व है उसको अब हमें समझने की जरूरत है, न सिर्फ जब हम एक आपदा के समय उसको समझे बल्कि तब भी समझे जब नॉर्मल भी हो। आपने न्यू नॉर्मल की बात की, तो अब न्यू नॉर्मल शायद ये भी होना चाहिए कि साइंस के महत्व को, टेक्नोलॉजी के महत्व को हमें समझना शुरू कर देना चाहिए और पॉलिसी लेवल पर इसमें बदलाव लाने की जरूरत है। बहुत बहुत शुक्रिया हमसे बात करने के लिए और इतनी अहम जानकारी हमारे दर्शकों को बताने के लिए। बहुत बहुत शुक्रिया Professor Ashutosh Sharma, Secretary, Department of Science and Technology, Government of India, for speaking to us and sharing your insights. Thank you so much.
शुक्रिया आपका भी, and all the viewers, all the friends, I wish them a safe passage through the time of virus. Stay safe, make everybody safe. May God bless us all. Live long and prosper. Thank you.
Thank you, sir.